Thank you, Esti, and thank you all for being here and giving me the opportunity to tell you more about the analytical tools that you will find in our platform in ArcGIS. So today I have a main goal, which is show you how you can access to all the analytical capabilities that ArcGIS provides through different apps at a different levels of complexities. But before that, I will give you I will give you a little bit of context because there are three important concepts that I want to discuss. Uh, and to start off, I think that the first thing that I want to share with you is that ArcGIS is not just a piece of software. It is a platform that integrates, that brings together three systems. The first system is what we call the system of record. And basically, the system of record is a concept that convey the idea that with ArcGIS you have a framework that will help you to integrate information that is coming from different systems, from different data sources, whether it is a spreadsheet or a corporate database that is connected to Epic or Cerner or other different systems that you are using in organization. This framework is powerful because in an easy way allows you to integrate that information by using location. And I will make the case that in this time nowadays where we are living in IoT world, most of our data is location related. Also, this data could be managed in different ways. Could be managed in your premises. This is important when it comes to analyzing HIPAA compliant data. When it comes to talk about the health sector, this data can be really deployed on your premises, on your own infrastructure, or on a private cloud such as Microsoft Azure or Amazon EC2. Or you can use our services as a SaaS, software as a service, by using ArcGIS Online. Obviously, this will depend on whether your data is PHI or not. Any kind of data you have, you can use our system of record. Then ArcGIS is also a system of engagement. That means that you can access to your data and to all the capabilities, the um, geospatial capabilities from any device, anywhere, at any time. And we have different apps. We have apps for the field. You can deploy ArcGIS in your cell phone and have applications that will allow you to navigate from one place to other, to collect data, to visualize your information, to manage crews. We have applications for the office, um, powerful applications for analysis, but also applications that could be used across the whole organization, and also applications that are for public-facing websites like cross-sourcing applications and so on. So it's a system of engagement. And finally, and that's my focus today, ArcGIS is a system of insights. It's a system of insights that have a vast amount of analytical tools that will help you to understand, measure, and even make predictions on your data. So let's go deep on what is a system of insights. Um, and there is a quote that I really like here, and this is the one. Data is important, however, not as important as the answers it provides or the stories that it tells. And basically, a system of insights will help you to ask questions to your data and receive answers. You can start with fundamental questions like where? Where is the problem? Where is it changing? Where should we locate our resources? But then you can go further and answer other more complex questions such as why? Why is it there? Why is it changing? Which implies the use of analytics to understand behaviors. And then my favorite question is why do I care? Right? Because at the end of the day, really what we are looking for is to answer the two first questions in order to determine the most efficient way to use our time and resources and to make a difference. And moreover, we really want to be able to look forward so we can be prepared for whatever is coming next. So all of these questions can be answered with the analytical tools of ArcGIS. Now, my presentation today will tell you how you can answer those questions by using different applications that would fit in different scenarios. You can start using applications that you already know today, such as Office. I'm sure that many of you have been using Excel or PowerPoint or Word. So we have an application that is called ArcGIS Math for Office that integrates the powerful capabilities of Excel and the science of Word. But also you can use more analytical tools like Insight for ArcGIS to leverage the power of iterative geospatial analysis in a completely new yet easy to use interface. And finally, I will finish my presentation by showing you the most advanced analytical tools that we have that includes some machine learning techniques that you can leverage by using ArcGIS Pro, which is our main desktop application. So let's start with ArcGIS Map for Office. Now, what is ArcGIS Map for Office? That's the first question I want to answer. So ArcGIS Map for Office is a plugin that you can install on top of Microsoft Office. And once you install it, you will have access to different capabilities. You will be able to visualize your information in new ways. You will be able to map your data from Excel to apply layer styles, to apply cluster points, or creating heat maps. Then you will be able to put your data in context. So you will be able to pull socioeconomic data from ArcGIS, create infographics, and even create these amazing reports that contains information related to specific locations that you are mapping. Finally, you will be able to analyze your data, and you will be able to create dry time areas and even finding nearby locations. And also, you will be able to create even hotspot areas that show you those areas where there are a statistical significant concentration of events. So enough of talking. I will show you right now the demo, but before that, just a couple of quick comments. Once you analyze, you will be able also to collaborate with your peers. So you will be able to share your information in ArcGIS Online, or even as an email, or sharing your project with your organization. And finally, to create a presentation by taking advantage of PowerPoint. So let's start with our demo of today. All right. So what you are seeing here is a spreadsheet that contains low beer weight data for South Carolina. Now, they are trying to decide strategically where to open new providers that can help tackle a trend of low beer weight in the state. Now, uh, I know this information because I am familiar with this data. What you are really seeing here are numbers, and some of them are even meaningless if you don't know the context. Fortunately, I have here ArcGIS map for Office, so I can add here a map. Let me add a map here, and I can put this information in context. So let's go ahead here, select Excel data. In this case, this table is called South Carolina low birth weights. Let's go ahead here, and I will map this information by using the zip code information that it has. And I want to create a map that shows the percentage of low birth weight birds in this range of years. So I will create a map, and very quickly you will see how easily I can map this information. There we go. So I have all this information mapped. Let me go ahead here because, yeah, there was a filter. So now you can see all the information mapped. And um, let me pull this. So the higher the rate of low beer weight birds, the darker the blue that you are seeing in this map. Okay, so the first thing I will do is I will filter the information in my Excel spreadsheet to see only those zip codes that have the higher rates of um, low beer weights. So let's go ahead here, put create a filter of greater than 10%. Click OK. You can see how easily and how quickly the map also is updated. And that shows you how integrated are these two components. So whatever you are doing in the Excel spreadsheet, you will see that depicted in the map. Also, what I want to do really is to take a more strategic approach. I was checking the CDC webpage, and there is a list of risk factors that contribute to increase these rates of low beer weight cases. Let me show you. I will open this link. Should be here. There we go. So you will see that there are some socioeconomic factors and even behavioral factors like smoking, drinking, low income, low education levels that are considered as risk factors for increasing the rates of low beer weight beers across the United States. So what I will do is to pull that information from the ArcGIS database so I can enrich my dataset and have a more in-depth analysis of these specific zip codes. What I will do to do that is go in here, go to enrich data. You can see how there is a vast list of variables. Actually, let me show you. If I go to health, there is data related to consumer spending, business summaries, and so on. So I can do a search, for example, for smoking, and let me go to all variables. Yeah, categories here, smoking. You will see how I can go to consumer spending and select this smoking products index, which is basically the index of how much people are spending in smoking products in that specific area. So even I can select this as a favorite, so I can reuse this variable for a future analysis. In the same way, I have here a list of favorites that I done before that will help me to bring information about alcoholic beverages, spending, household below poverty level, household with no vehicles home, also people that don't speak English, they just speak Spanish, and the projection that the statistician team of ESRI has done for the median female age for 2023. So I will use these variables to enrich my spreadsheet and to have a deeper analysis. So if I click Add Data to Worksheet, it will create new columns and it will populate them with that data. I done that already, and let me show you how it looks. So let me put this a little bit here, and you can see how all those variables now are here. All right, so we have all these index and variables that are definitely impacting the percent of low beer weights in South Carolina. So what I can do now is use the power of Excel. So let me show you how I will do that. What I can do is to create a formula. I already did it here that take each of those variables, as you can see here, and applies a weight to each of those and normalize the result. So I can come up with something is not, there we go, with a new index that shows the risk that each of these zip codes have to have future low birth weight birds in that specific area. And once I create this specific index, the next step that I can take, let me put this here, is to filter my information. So I can go ahead here and say, you know what I want to do is all those specific areas that have more than eight um, in this specific index are those areas that have uh, the higher percent of lowers, but at the same time the higher risk of future low birth weights. So I have to prioritize them if I will do any kind of intervention in this zone. Moreover, what I can do now is more spatial analysis. And actually, I have here another tab, another table of information that have information related to my providers. So I can go to Excel and add now my providers table. Let me go ahead here, providers table. And now what I will do, let me show you, is a process that is called geocoding, which is taking the addresses of these uh, routes of these specific points and map those, generate the coordinates of these specific addresses. And I don't need to symbolize them. So I will geocode these specific providers. And then you can see in the map how this is processing. So let me go ahead here, put the map in the center. There we go. So you can see now how these providers are mapped. Now, let me show you something really cool. We will do an spatial analysis here to finalize our strategy for creating new providers in South Carolina. What I will do is go ahead to providers and I will do a find nearby area. I will select all these providers. Let me go ahead again, like a couple of those. There we go. All right. And then I want to find all those zip codes that are not, but that are inside a dry time area of 30 minutes, within a 30 minutes dry time area from providers. So I click here, next. The target layer is the zip codes. I run the analysis, and as a result, what I will have is all those zip codes that are within this 30 minutes dry time. Internally, what the software is doing is running on top of our network data set that we have for all the United States, and is calculating the driving time for each of these um, providers. So there we go. Now, if I select all these zip codes here, let me show you, highlight selected routes. What you are seeing here in the zip codes, uh, software is highlighting all those zip codes that are within the 30 minutes driving time. But what I will do now is something really cool. I can show only those selected routes, which is only show those um, zip codes that are within the 30 minutes dry time, and then I can create a new column named drive time or drive time or nearby. Use the number 0 for those that all those that are within the 30 minutes dry time, and then I can invert the selection and only show all those zip codes that are not uh, in those specific areas. So you can see how here there is a cluster of zip codes that not only have a higher percent of low birth weight um, birds, but also a high risk of future low birth weight um, cases, and even they are not within the 30 minutes dry time of the providers. So definitely I will suggest an intervention here, probably looking for a provider in this specific zone. The same here. There is also another cluster here that could be easily solved with hiring a new provider here or doing an intervention here. So you can see how this powerful analysis can be done by using Esri Math for Office. Thank you.